Hello, everyone, and welcome on board. Thank you for taking the time and joining us today in our webinar. Our topic for today will be about engine and alternator duration. I see many familiar names. For you guys who don't know me, my name is Mustafa Haziem. I'm a sales engineer here in Jubaili Brothers. I'm handling Dubai territory. I have a bachelor degree in mechanical engineering from the American University of Sharjah, and I hold an MBA from the University of Wollongong in Dubai. Hi, Muhammad. I started my career in the construction field. 4.5 years later, I decided that I had my fair share of sunburns and decided to join the sales force. We can't hearing you. Is there a problem with my mic? No, it's all right. It should be all right, Muhammad. Uh, anyway, so I started in the construction field, and 4.5 years later, I decided that I had my fair share of sunburns and decided to join the sales force. Sales is the place where I found my passion. It's been 2 wonderful years for me here in Jubaili Bros, where every day is a new learning experience. This photo, by the way, was taken last year in our exhibition in World Trade Center. I don't know if you guys were there or not. Sitting behind me is a 250 kVA, beautiful Jubaili genset. Now, moving on to today's agenda. For you guys who are new to us, I'll start by introducing Jubaili Brothers and our development over the years. Then we'll go to our product range. What do we offer? Then we'll go to the heart of our topic. What is duration? What are the contributors that affects duration on the engine and alternator, of course. And then we'll have two examples, one as a general inquiry and one in the form of construction or a project inquiry. And then we will conclude with the key points that we have learned in our webinar today. We have been in the power solution industry now for 43 years, turning 44 this year. We are operating in 10 countries worldwide. We have 3 manufacturing facilities in countries UAE, Lebanon, and Nigeria. We have 29 branches and service centers worldwide, more than 1,300 employees, and 70 dealers and distributors who are even physically present in the countries that we are not operating in. Jubaili, we started in 1977. Our first expansion was to UAE 30 years ago, and the rest is history. Then we expanded to Nigeria, Afghanistan, Kuwait, Ghana, Qatar, Uganda, South Africa, and our latest quest was last year in Pakistan, where we have opened our solar department. For genset, we are powered by Perkins engines. For alternator, we've got 3 options: Leroy Somer, Mikati, and Voltas. For control panel, we use deep sea electronics. Our breakers are ABB. This is a slide which I find really interesting. This shows our growth over the years. As you can see, in 2010, we had around 3,200 engines procured from Perkins. In 2019, if we compare it from 2010, there has been a 500% increase in our genset sales. So it's a remarkable growth, if you ask me. And this year we are planning to hit our 20,000 units record. Now, when it comes to our product range, we have 2 products in Jubaili, and this is something that I want you guys to focus with me. Like, we have Jet and Morocco, both have the same components. However, one is assembled in UAE and the other is assembled in UK. Both of them, they have the same engine, same alternator, and same control panel. The only difference is the manufacturing location or the assembly location. One is assembled in UAE, the other is in UK. Now, when it comes to our generator types, there is the open types that we all know. We have the canopy type and we have the containerized type. What is the point, or why do we use containers instead of canopies and bigger capacities? Now, our goal is to reach 80 to 85 dBA sound level at 3 meters. So it's really difficult to reach this noise level at higher capacities when we are using a canopy, and therefore we use containers. 1,000 kVA and above, we also go for 40 feet container type to ensure that the sound level emitted is in that range, 80 to 85 dBA. By the way, we have also our super silent canopies that are customized to meet the client's specifications. They can reach up to 78 dBA at 1 meter. To the components again, we have Perkins engines for our gensets. Our alternators come as the Roy Sommer, Voltas, 𝐂𝐤. And the control panel, which is the interface between the end user and the machine, we use deep sea electronics where we can get different parameters such as voltage, ampere, frequency, and so on. Moving on to the capacities that we offer, our range starts from 9 kVA, the 400 series, and we reach the 4000 series up to 2250 kVA prime, which is 2500 kVA standby. So we have different offerings depending on your need. We can offer you the genset which is suitable as such. What is duration? Now, what is duration? Duration, let's start by a quick general information. Now, all engines and alternators are designed to give you an output at certain environmental conditions which are provided by the manufacturer of the engine and the alternator. If these environmental conditions are not met, the engine and the alternator will not operate at 100% of their design capacity. This loss of power is called as duration. In other words, decrease in efficiency or loss in efficiency. Duration, it is a very critical factor that the specialist and the end user should bring to the table and discuss and talk about before selecting their generator. And we will talk about that in the examples which are coming in the next slides. Now, when it comes to duration, we said environmental, in the previous slide, we said environmental conditions. What are these environmental conditions? There are two factors that contribute to duration. First one is temperature, and the second one is altitude. We start with temperature. Now, as the ambient temperature increases beyond the design operated conditions, the engine and alternator derating begins, therefore decreasing their efficiency. Temperature has an inversely proportional relation with efficiency. So the higher the temperature is, the higher is the duration. This is a photo of two generators that were supplied to the middle of the desert in Abu Dhabi by us. Before we supplied it, we sat down with the customer and we had a big discussion about duration because these generators were going to place in very harsh weather conditions. So we checked the connected loads, we checked the duration factors, and after that, we told the customer that we think that these capacities will work with you, and we moved ahead. The generators have been operating for 1.5 years so far, and they're operating in smooth conditions. Now, why does temperature affect efficiency, or why does temperature cause duration? The reason behind this is as ambient temperature increases, the density of air decreases. Therefore, air will hold less oxygen. How does that affect the engine? The efficiency of diesel burning in the combustion cycle decreases. Let me show you a small experiment that I found online. Now, some scientists did an experiment and to show the relation between temperature and density by keeping pressure constant. If we look at the density of air at 20 degrees Celsius, it is at 1.204 kilogram per meter cube. While at 50 degrees, it is 1.109. There's a difference of about 8 to 9% in these 30 degrees difference. And therefore, we can see that the air is less dense and therefore it can hold less oxygen. And this will affect our engine accordingly. Now, how does temperature affect the alternator? The higher the ambient temperature gets, the higher would be the temperature rise in the copper present in the alternator windings. This, therefore, would lead to a higher resistance, which will cause losses in the alternator efficiency. We always need to take care because when ambient temperature reaches a higher point than the values mentioned in the testing conditions, this could lead to overheating and possible degradation of the winding resistance. The photo on the bottom right is how the windings look like. So this is how it does affect our alternators. Now, when it comes to altitude, how does altitude affect our engine alternators? Let's go to the concept wise. At higher altitude, also the density of air decreases, just like temperature in the previous slides. So this decrease in density also reduces the oxygen levels present, which decreases the efficiency of both the engine and alternator. Therefore, a generator which is located at a higher altitude than the desired conditions will have a drop in efficiency and duration will occur. Uh, this is a nice example about showing the relation between oxygen levels and altitude. At sea level, it's 100%, all right? If you compare it at 30,000 feet, which is almost the peak of Mount Everest, the oxygen levels are at 1/3 of what we are getting on the sea level. So, like the mountaineers who climb Mount Everest, the problem is not only the physical intensity of climbing the mountain, also the fact that oxygen levels are very low on higher levels. There is a nice quote that I found online of a mountaineer who climbed Everest. He said that it feels like running on a treadmill and breathing through a straw. That's how difficult it is, and that's how low oxygen levels are as higher we get. Now, and by the way, for the alternator derating table, which I will show you next, it will show us the maximum levels up to 3,000 meter altitude, which is at 10,000 feet approximately. We will discuss this later. Now, how do we get the duration factors from the charts and tables that we have? Engines, usually it comes in the form of charts, all right? So this is example of how a chart looks like. So it shows us the relation between temperature, altitude, and the output of the duration factor, how much will be the duration percentage. This is quite good engine because at 50, okay, the 50 degrees is the orange line, all right? So the orange line is indicating the 50 degrees Celsius. At zero altitude, at sea level, which is our UAE conditions, there will be no duration. Duration will occur at the 50 degrees Celsius at 1,700 meters almost. That's when you will start to have a duration. At 2,100 meter, 50 degrees Celsius, you will have only a duration of 5%, which is a really good engine if you ask me, because if we look at the next example, this is another chart taken from one of the engine duration charts. At 50 degrees Celsius and zero meter altitude, duration already occurs at 4%. So if we are operating at 50 degrees Celsius, 0 meter altitude, you already have a duration. Another example of an engine, this is high duration percentage. Here, the black line is indicating 55 degrees Celsius. At sea level, it's already having a 15% drop in efficiency. So if 100 kVA, if this graph is for 100 kVA engine, it will give you 85 kVA at 55 degrees at sea level. If we go up to 2,000 meter, it will have around 25% decrease in efficiency. So we need to take that into consideration, and we need to inform our end users who will be procuring to the generator. We need to ask them where they are taking it, the location, and so on, to let them select the right generation for their use. On the other hand, the alternator duration can be taken from the table which is shown in front of us. It's not like the chart, it's constant for all models. You have the ambient temperature on the top, you have the altitude on the left. So if I have an inquiry for 45 degrees and 2,250 meter, what do? I go to the 45 degrees, which you see here. 2,250 is in this range between 2,000 and 2,500 meter. So it will have an 88% efficiency. So the duration percentage will be 12%. Moving on to examples. So we'll have two examples, as we said, a general inquiry example, and the next one will be from a construction project. Now, a customer could come to Jubaili and they'll ask us for a 100 kVA generator suitable for Dubai weather. As a sales engineer, I will take 4 steps to quote or to propose to the customer the right generator for his use. First thing, I will check the country's maximum ambient temperature. Second step will be checking the country's altitude. Then I will be going to the engine duration chart, which we have seen in the slides before. And then I will go to the alternator duration table to check how much is the percentage of the duration. So for Dubai, the ambient temperature is around 50 degrees Celsius at its peak, of course. The altitude, sea level. Engine duration chart, now we'll have a look at them. So I took the example of the chart which we have seen earlier at 50 degrees, which is the line at the top, which is in orange. I don't know if you guys can see that, but at 50 degrees, zero altitude, you will have no duration from the engine. So engine at 50 degrees, it will give you 100 kVA engine will give you 100 kVA power output. On the other hand, the alternator at 50 degrees Celsius at 0 meter altitude will have 94% efficiency, and the derate factor will be 6%. So the engine will have no problem. The alternator, 100 kVA alternator, will give you an output of 94 kVA. So what do we do here? We'll go to the client. We'll tell him that, okay, our 100 kVA model, engine-wise, you will not have any problem, but the alternator at 50 degrees, you will expect a 6% drop in its efficiency. And you will only have a power output from the generator as a whole at 94 kVA. So what can we do in this case? Since the duration is only from the alternator side, okay, we can propose to the client upgrading the alternator. Not the full, because we have 100 kVA. Next one is 135 kVA model. So instead of upgrading the full genset model, all right, which will have quite the commercial impact, we can advise our client to upgrade the alternator only. If he upgrade the alternator to the next model, we couple it to the 100 kVA engine, you will have 100 kVA at 50 degrees Celsius, and you will not have any issue with the duration. Now, next example is project inquiries. I get many inquiries from contractors through the phone. Mustafa, just send me 100 kVA quotation for standby application of project. Now, I wish it's this easy. Now, to quote a project for you, there is 5 steps that we take, all right, to quote something that is complying to the project specifications and that will function properly with the load that you have at the site. What are the 5 steps that we take? First thing, Mr. Contractor, we require the single line diagram from you, and we need the MEP specifications related to the generator. Second step we take, we open these MEP specs, we go to the generator section, and we check, is it a prime rated genset that is required, or is it a standby rated genset that is required? We all know that is going to a construction project, and it will be in a generator room, which will work only if there was a power outage. It will work only as a standby or as an emergency. But some specifications, they ask you for a prime rated genset. We will go into details into that now, but this is the general idea. Third step and fourth step, like the slides before, we will go for the engine and alternator duration table and charts. Last thing, we'll advise the contractor on the right selection to comply to his project's specs. So this is a single line diagram example. This is how usually it looks like. So once we receive it from the contractor, we open the single line diagram, all right, and we check the rating that's mentioned. Now, what's mentioned here in this example is 150 kVA standby diesel generator, all right, 8-hour day tank. Okay, we'll ignore the last information. Now, what we want now is to look at the capacity. What we have here is 150 kVA standby diesel generator. Now, standby diesel generator does not mean that it should be standby rated only. It could be prime rated. So here we took the capacity. Step number 1 done. Next step is to open the MEP specs and check, is it prime or standby rated? So these are examples that I took from some project documents that I have. The first example, it straight away tells you I need a standby rating for my genset. Second example, also the generator shall be standby duty. So it should be standby rated, all right? The third example, if you look at the bottom, it also tells you that the generator rating indicated on the drawings, which is the single line diagram which you open now, is the standby power rating of the diesel generator. So we need to consider standby rating when we are giving our proposal. Now, second thing that we check always from the specifications, we are familiar with UAE specs, so we always look at temperature, because UAE does not, the altitude is always at sea level. But let's talk about two things that we also check from the specifications: temperature and altitude. These are examples of how the consultant usually specifies the required temperature, operating temperature. The first example, they're asking for an operating at 52 degrees Celsius. The second example is 50 degrees. And the third example is usually 50 degrees. In many cases, they usually ask for 50 degrees Celsius, which is the peak temperature in UAE. And also, there is a safety margin there, because most of the gensets are inside a generator room. So you don't really reach 50 degrees Celsius in the generator room, but we need to comply to what's written, and we don't need to take our assumptions when we are quoting for a project. So what are the outcomes that we came with? First outcome, the generator should be 150 kVA. Second outcome is that it's a standby rated. Third outcome, we have to consider 50 degrees Celsius. Fourth outcome is that the altitude we need to consider is at 0 meter, which is sea level. Now, given these outcomes, a generator of 150 kVA standby rating is required. What do we do in this case? We don't propose JP 150 model, which is 150 kVA, 165 kVA standby. What we will do in Jubaili, we will offer the customer, or because there is a cost impact there, what we can do, we'll offer him the JP 135 model, which have an output of 135 kVA at prime and 150 kVA at standby. Engine duration at 50 degrees Celsius, it is 0. So it will still give you 150 kVA standby rating, but the alternator will have a duration. So what we will do, we will tell the client that in order to give you 150 kVA standby rating at 50 degrees Celsius and 0 meter sea level, we will give you our JP 135 model, all right? But we need to upgrade our alternator to avoid duration at 50 degrees. And this complies to the project requirements, and at the same time saves money for the contractor who is doing the construction at the site. Now we come to an end of our webinar today. I want to recap what are the key points that we have learned in our webinar. Duration factors. It's very essential when we are selecting the right generator, all right? You need to give us your requirement as an end user, all right? Where should the generator be located? Where it is intended to be used? In which country? What's the altitude there? What's the peak ambient temperature in that location, all right? It's the salesman's responsibility to quote you and to propose to you and give you options of what generator will be suitable for these environmental conditions and show you these on the charts. Rating specified as our key inputs when selecting a generator. When it comes to construction projects, all details should be provided by the contractor, single line diagram, MEP specifications, so that as a specialist, we quote for you a proposal that is complying to the project requirements, and so that we can save you money by complying to the project and not giving you an extra size. Finally, these are my contact details. You guys can save it. If you have any questions, inquiries, or you only want to drop a hi, you can always contact me on my number or send me an email on my email address. At the end, I would like to thank you all for attending this webinar. It has been a pleasure. It's my first webinar in Jubaili. I hope you guys enjoyed it and that you have learned some key insights of the generator business. And stay tuned for more webinars to come.